Hello and welcome to our Technology Showcase. I'm Clayton Pattison with Fruno Technical Support.
And I'm John Korn. I am the Northwest Regional Sales Associate.
And today we're going to talk all about radar. What they are, how they work, and how to select the best one for your application. Now, we're going to mainly focus on the light marine product line, which is the TZ Touch 3 and 2 series systems, and their radar antennas and radar options. We are going to touch on some standalone stuff, and we'll maybe touch on a little bit of commercial, but we're not going to get too deep into the weeds because we've got a lot to cover. And we also want to get to your questions because we're going to do a Q&A session at the end. So if you guys want to submit questions during the presentation, please feel free, and then we'll get to as many of those as we can at the end.
Yeah, right. So let's dig into the first question that I always get at the boat show is, what radar do I choose?
That's the biggest. And first, we're going to I want to step back and do a little bit of history, quick history, and some kind of basic operational theory on how they work. So radar has its origins in the mid-1930s, and the acronym radar, R-A-D-A-R, was coined by the U.S. Navy in 1940, and it stands for radio detection and ranging. So it allows you to detect a target and then determine the range relative to own ship position.
Right, so it gives you live navigational data around your boat.
Exactly.
Where chart plotter's been charted, radar gives you live data.
Exactly.
Which is nice.
Now,
essentially, radar technology hasn't changed much since the mid-1930s.
No, it really hasn't. And basically on a basic level, it really hasn't.
Right, but now in the last 15 years, there's two advancements that we offer. Two different types of radar, which is a magnetron radar and a solid state.
So radar, as in general, how it works is voltage is applied to the transmitter. The transmitter, which functions, will send out RF or radio frequency energy out through the array. It'll bounce off a target. It'll come back into the receiver and be processed into the targets that we see. Not only does it let us see those targets and where they are, but it'll also let us determine the range based on the time it takes for the beam to exit the radar, bounce off a target, and come back. It will allow us to figure out what their range is relative to our location.
That's good. That's good information. But now let's dig into how do we choose one.
That's the biggest question. Every boat show that John and I have ever worked over the years, that's the biggest question is, what radar do I choose? Right. Well, to answer that question, we really have to ask three more, which are, what type of boat is it? What's the application? What are we doing with it? And how much room do you have for the antenna on the hardtop?
Because radar gives you really three main functions, which is collision avoidance, weather detection, and bird detection for fishing.
Yeah. So basically, with weather detection, we're using the radar to find weather formations like rain squalls are a big one, so that if you can watch them move in, you know what to avoid and stay out of the rain and have issues.
Same thing when it comes to like bird, but
yes,
you can see
actually we got an image up here on the screen that actually shows what a rain squall or rainstorms look like on a radar image. So if we can use the radar to detect them, it'll help us kind of avoid those and for better fishing in a better environment.
Yeah, actually it's really helpful. I mean, it's pretty simple too nowadays, especially with our newer radars. We have that ability to turn it on and off, and it tunes it right.
And it'll tune the radar specifically for that, and I think it'll even set it as the right color too.
Right.
So we can just basically separate it from the rest of the targets. Now, bird detection is also big because the best fishermen out there are birds. So if we can find them, we can find fish. This is a big thing for big sport fish boats and commercial fishing vessels that are looking for that kind of thing, to have that ability to pick them out.
Right.
Which I think we've got a clip of that too, so we can show you what birds look like on a radar. So if you're using the radar with a narrow beam width, in the bird mode, we'll actually tune the beam so we can actually pick out these small little targets, and they'll show up like this on the radar screen, so we can actually pick up those birds diving into the water, so we can actually hit them and catch fish that way.
So the fish can't hide.
No, they really aren't, no.
Right.
So the next question we have to ask as far as application and installation is standalone versus MFD, or multifunction display.
Right, so that's another big question too, because a lot of times if you want redundant, and we'll talk about that when it comes to our MFDs and the standalone. But first we're going to touch base on our standalone radars. So the first we're going to look at is an 1835 series, because we offer this series and a dome to an open array version.
Okay.
With an 1835 series, you can only have up to one remote display.
Okay. So we can actually remote connect a secondary display to the primary one, correct?
Right, right. And the nice thing about that, if you want an open array, we offer from a 3.5 foot to a 4 foot or to a 6 foot.
Okay.
With that gearbox.
So and the 1835 series has two different options for antennas as well.
Mhm.
We've got the 4 kilowatt dome.
Right.
There's the 4 kilowatt open array.
Right.
And the 6 kilowatt open array as well.
Right. Correct. So, but if you want a standalone radar, you need more displays to have around the boat. Then
Okay.
you're going to look at something like the 1835 series.
Okay.
So I do apologize. 1815 radar. It's because the 1815 radar you can have up to 3 displays
Okay.
But-
But we can connect those together how?
through Ethernet. And so,
Really? Okay.
so the thing about the 1815 display, it's only compatible with one radome.
Okay, so it just has one single radome
Right.
option, but what it does give you is the ability to network in up to 3 displays.
Right. So have 3 units instead of just having one standalone.
Yeah, and I think there's one more option that we offer as far as small light marine standalone radars,
Right.
which is an industry first.
Yeah, which is our DRS-4W.
Mhm.
So the DRS-4W is compatible with an iOS device or
Okay.
our GP series.
Okay, so it's a wireless radome that we can tie into one of our plotters or an iOS device. The plotter will allow you to do what's called radar overlay. And radar overlay is a feature that I really like and I really use as an example for beginner boaters. What it'll do, you have to have a heading input to do it, but what it will do is it'll overlay the radar target information on top of the chart so that you can compare them together. And it gives you that extra level of situational awareness for safety, and especially for a beginner boater. Because another one of the most common questions that we get at a boat show is, what am I looking at? When you're looking at a radar screen and you don't understand what you're looking at, how do you interpret that? Well, radar overlay gives you that because it'll compare that image to the chart and you can understand, okay, this is landmass, these here are targets. And I'll give you an example. So on the TZ Touch 3 19-inch, which is a great segue into MFDs, we're going to get into them next.
Right.
If I swipe up, actually no, I don't want to swipe up. If I go here and I go to my chart plotter, and then I edge swipe up from the bottom, I can actually turn on my radar overlay here. So if I have it on, you can see that it's overlaying the radar data on top of the chart, so you can see where it matches up to the landmass. And then up here in the channel, these targets here, these are boat icons. So these are boat targets, vessel targets. So these are the ones we want to pay attention to. But it gives us that situational awareness to understand where this stuff is in relation to where we actually are.
So having an overlay is actually a huge advantage when it comes to MFDs.
Oh, it's big.
Yeah, so, and with our MFD product line, it's compatible to the original DRS. So DRS stands for Digital Radar Sensor. So from that to a DRS-X class and our Drs-NXT series. So the nice thing about having an MFD, besides having an overlay, you have that option to have that overlay, but you need data to make it work, such as
Heading.
and GPS, right?
Yep, you need to have GPS and a good heading fix and a heading sensor to do it, yes.
Right. But when it comes to having a standalone, I mean, that's all you get. It's just a radar.
Yeah, it's just a radar
Right.
picture.
The nice thing about having MFD, it is redundant. You can't, where before people used to be like, I like having redundancy on my boat.
Yeah,
I
a
like
separate radar, a separate
Right.
chart plotter, a separate sounder. That was kind of the gold standard for redundancy.
Right.
Now, with the network systems, you've got 2 or 3 of these MFDs on the boat. They're all networked together, but they're all independent because they're all on the same network. They're all talking directly to the radar antenna, directly to the sounder, and directly to the NEMA 2000 backbone. So in the rare off chance that you might have an issue with one, the other ones are still on the network and are still fully functional.
Right.
So you're not going to lose anything, which is nice.
Yeah, right. So you have that option. Again, standalone or MFD, really up to what works best for you and your application.
Yes.
So
Now, the next big question is, that kind of comes along with how do we pick a radar, is dome versus open array. All right, so they're very different. They do the same thing, but they have very different pluses and minuses
right.
to their construction, how they work.
So you can pull that. Show me
So
the
with a
right
dome, for example, so a dome radar, like our dome here, a dome is traditionally a lower power but with a wider beam width, which basically translates into good short-range target detection.
Right. Where an open array is higher power, gives you a more narrow beam width for a longer range target separation and resolution.
Yes.
So when it comes to open array, we offer 3 different types for the DRS X class or the original ones.
Any of them, really.
Yeah, anyone, all of them. So, and when it comes to beam width, where a dome is about 4 degrees horizontal, a vertical is about 20 to 25 degrees.
Yeah, depending on the radar, it's anywhere between 20 to 25 degrees vertically. The horizontal beam width is the important one, and I'll explain that in a minute, just what that means.
Right. So when you have a 3.5 foot, is the horizontal beam width is about 2.3 degrees.
Yep, 2.3.
When you bump up to a 4 foot, it's 1.9 degrees, and when you go to a 6 foot, it's 1.4 degrees.
Okay.
The easiest way to think about it is the longer the stick, the more narrow the beam.
Yes. So when we talk about beam width, and we'll just take a little bit of detour and I'll explain this because it's very helpful, and I use this at boat shows all the time. How beam width works is, think about a flashlight. Now, if I take a flashlight and I open the beam up real wide, and I go out in my backyard at night and I shine it across the yard, I can see most of the yard, right? I've got good coverage, but the light's kind of washed out because I'm dispersing all that energy into a wide coverage. So the light's kind of washed out, it's kind of dim, I can see everything, but not very well. Now if I close down that beam real tight and shine it across the yard, now I can pinpoint and I can see a target real well because I've focused my energy and I'm putting more energy on the target that I'm pointing at, right? So I've got, it's real bright, I can see it nice and clear, I can still see the rest of the yard, but what target I'm looking at I can see nice and clear because I'm focusing all that energy on that target. That's how a beam width works.
Right. It's
between
more
narrow and wide.
Right. Target separation.
Exactly.
To help you or 2 targets.
Exactly.
Which is actually pretty nice. And that's a good explanation on the analogy on how you're using the flashlight, because that really works. I mean, to put into a visual perspective.
Yes.
It's really nice. But the next big question is magnetron versus solid state. So a magnetron, when it transmits at a short pulse but higher energy that provides stronger return.
So in a solid state radar is going to do essentially the same thing, but it's transmitting on a longer pulse, slightly lower energy, but what it does to make up for that is that it's transmitting on a different frequency range to stay as effective as a mag radar while not losing anything.
Right, so it's like equivalent to it.
Yeah, it's essentially doing the same thing, it's just doing it differently with a little bit different specifications.
Right. So when it comes to power,
Yes.
so a solid state dome that we offer, like our Drs-6a
Like this guy right here.
Nxt, is 25 watts.
So it's outputting 25 watts of transmit power, which would be the equivalent on a magnetron radar of about 4 kilowatts of power.
Right. So now the next question is, we offer a step up, which is our Drs-6a Nxt.
Now, this is one I wanted to bring up, and I'm glad you mentioned it, because the Drs-6a Nxt is also transmitting the same 25 watt output. It's essentially the same transmitter. But how is it making such a better use of the power over the dome?
Utilizing one of these bad boys right here. So again, when I was mentioning earlier, the beam width on what size array, where the Drs-6a Nxt is an open array radar. So when you have a 3.5 foot, your horizontal beam width is narrower than a Drs-4D Nxt.
Narrowing the flashlight.
That is correct. So I mean, that's very, those are like the main difference between the two. So.
Yes.
But the biggest one is, what is the advantage of a solid state compared to a magnetron?
So with solid state versus magnetron, the biggest deal is maintenance, right? So the magnetron is essentially like a radio tube, an old radio, where it generates RF energy just on a larger scale. Same principle, but larger scale. They do wear out over time. They are a lifespan item, so they're going to eventually fail. So a solid state radar doesn't have a magnetron.
So it makes it lower maintenance.
Yeah, it's considerably lower maintenance, less to wear out, and less problems.
Right. So while we're on this topic, just want to bring up an X-band versus S-band, because I know we get those a lot too.
Oh yeah, we should probably bring that up too.
Right,
because so X-band and S-band are a little different. X-band radars, at most recreational radars are going to be X-band. So the ones you see out on large, cruising boats and pleasure craft and stuff, all of these guys, they're all X-band radars.
Right.
And they're going to transmit at a higher frequency, so between 8 to 12 gigahertz. And they're going to utilize the shorter arrays like these, like the 3.5, the 4-foot and the 6-foot array, with a fairly decent beam width.
Right. Where an S-band uses a lower frequency, which is 2 to 4 gigahertz.
Yes.
And it utilizes a bigger array.
So we're talking
9 foot is the smallest array that it can use.
Okay.
So it goes from a 9 to a 10 to a 12 foot.
So maximum of 12-foot array. So
Right.
we're talking container ships,
Yep.
cruise ships, big, commercial fishing vessels,
Mega
something
yachts,
that needs,
huge.
some major transmit power and
Right.
some real fine target
Right.
detection.
But those big boats, you usually see an S-band and an X-band. So they usually put both on those.
Yeah, in a commercial applications, you might see both. You probably won't see an S-band in a small application, not like parked on top of a 36-foot yellowfin. I think
Right.
it would be a little bit overkill. But we'll see more in commercial applications.
All right, so let's shift gears now and let's talk about the 3 cool features that our DRS offers.
Yeah, so let's talk about DRSs, like Johnny said. There's going to be 3 main options. The first one is fast target tracking. Now, I'll get into that. We're going to rewind a little bit. We're going to talk about Arpa first, which is automatic radar plotting aid, or target tracking. So in years past, and with some of the standalone radars that are out here, we can do 10 targets at one time, automatically track 10 targets at one time. So it will acquire a target on the screen, the 10 closest targets, and it will track them. It'll keep an eye on that target so you can watch out which one's going to be a collision possibility or not. And it will maintain and track them automatically.
Right.
Well, when we came out with the DRS series for NavNet 3D in 2008, 2009-ish, we could do upwards of 30 targets at one time. We're the only one in the industry that can do that many targets. And when we introduced the NXT and the X-class radars, we can do upwards of 100 targets at
That's
one
a
time.
lot.
That is a lot of target information to be tracking at one time. And we do it in a special way, which is the 30-40-30 rule is the way we put it. So that's 30 targets automatically, 40 more manually. So automatically means it will automatically pick the 30 closest targets to you and track those. Manually means you touch on the target that you want to acquire and tell it to acquire it, and then it will track it. And then there's 30 more via guard zone, which the guard zone is basically an invisible guard zone or a barrier around the boat that you can set the parameters in the menus on the MFD, and it will allow you to create this area that when a target enters the area, it will automatically start tracking it. So say, for example, you're in a crowded mooring or at night anchored up and you guys want to sleep and don't want to get hit in the night, this thing will maintain that area, and any target that enters it, it will then start tracking it and can alarm or two and tell you where they are.
Which is nice. How about ARPA versus MARPA? We get those questions a lot too.
So ARPA versus MARPA. So MARPA stands for, it basically is mini ARPA. And what it'll allow you to do is to track up to 10 targets manually. It doesn't do automatic acquire, so you can manually select and track 10 targets. ARPA is automatic. And the cool thing is with the fast target tracking, which is the root of this whole thing here, circle back around to the beginning, fast target tracking is, in the old days, it used to take upwards of 10 rotations or sweeps of the radar to actually lock in and acquire a target, right? It'll pick it up, it'll think about it for a while to make sure it's there, and then it will acquire it. Well, with fast target tracking, it's instant. As soon as it's grabbed it, it's tracking it. Done.
Boom. So, Clayton, let's show them, the viewers out there, how easy it is to use ARPA.
Yes.
And turn it on our.
So
easy
if we
touchscreen.
want to turn it on, if I edge swipe up from the bottom here, and I can turn on ARPA targets, now seen here on the radar screen, all these little red, green circles here, these are all ARPA targets that it has acquired and is tracking. Some of these little blinking diamonds here are targets that it has lost. But each one of these targets has a little heading vector on it, which shows you which direction the target is facing or which way it's going, so that we know which one may or may not be a collision problem that we can keep an eye on. But it's tracking all of these automatically here on the screen.
So I noticed when you swipe up,
Mhm.
there's all these other cool features that you can offer on the radar.
Yes, and we'll touch on a couple of these. So I can turn ARPA off, and I'll turn AIS on, which stands for Automatic Identification System. So just real quick, AIS is a transponder, so it's got an antenna. You put in your boat information, your MMSI number, which is usually given by the Coast Guard or a number of different places, your boat information, speed, course, and so forth, and it will then transmit that out into the world. Whoever else has an AIS transponder or receiver can receive that. They can see you on their radar screen or chart plotter, and you can see them if they're transmitting. So they can see you, you can see them, and it's not line of sight like with ARPA is. So if they're behind a landmass or behind a mountain or behind a tanker ship or something, you can still see them, which is the nice thing. So we can turn those on and off, and obviously we've got a couple of different colored targets here. So the blue targets would be Class A, which is kind of more of the commercial style AIS that's required for regulated vessels that have to have it. The green ones here are Class B. Those are targets, transponders that are, for everyday use, for a, cruiser or a small boat, someone that just wants to have an AIS that's not required to have one. I'm not going to go in any more depth than that.
Right.
Just because we could get lost on these things and do a whole show on AIS.
Yeah, so and also when you swipe up, you
Yes.
have those different modes on top.
Yeah, so if we turn off AIS here for a second, we've got Target Analyzer, which we'll talk about in a minute. We also have rain mode. So this is what we were talking about earlier for weather detection. So if we turn on rain mode, it's going to turn everything else green, and it's going to pick up the targets that it thinks are either rain squalls into, we'll usually show them in blue. On our target as a big target, so we can see where the rain's coming in and differentiate that from our landmass or from our boat targets. We also have the bird mode, so we can put that in calm, moderate, and rough, and that'll allow us to use our bird detection that we talked about earlier to kind of help tune the radar specifically for birds, to pick those up in a small target. Obviously, we don't have birds in the studio, but I think we have a quick clip of the target, the bird mode in use that we may have played earlier, but here it is again. So you can see the birds diving on fish here. There's the birds actually showing up on the radar, and this is what we're looking for when you're doing a lot of sport fishing. They'll follow the birds to find the fish.
Right.
So the bird mode will actually tune the radar specifically to find those.
Which is nice because, in the past, we used to always say tune the radar manually to get the
Yes.
birds to fine tune it.
And there's a whole
There's a
a whole way to do it. I remember walking people through it with some of the big 12K radars
Right.
with the 6-foot antennas,
Correct.
so specifically to pick out birds. But now we've made it a whole lot easier.
Way easier. So the next feature that I want to mention is called Res Boost, which is resolution booster.
Mm-hmm.
So that one is actually really cool because what it does, it helps you narrow the horizontal beam width
Mm-hmm.
from a 4 degrees.
Like we talked about before with the flashlight, it allows you to narrow that beam down.
to down to 2 degrees. Especially you see on our Drs-6a Nxt dome, there's going to be 3 settings. Besides standard, you're going to have your standard, and then when you go in Enhanced 1, it will sharpen the beam. Enhanced 2, it will go to a sharper beam. And Enhanced 3 will give you the most out of it and use it down to about 2 degrees.
I think we have an example of that, don't we?
We do.
So this image here shows kind of how Res Boost works with standard, Enhanced 1, Enhanced 2, Enhanced 3. Now you can see in the standard mode that you've got these mooring dolphins here, which are basically piers that the boats and ships can tie up to. In standard, you can see they're kind of, the resolution isn't as sharp, and they're kind of, it's not as clean.
Right.
But as you start going through the different enhanced modes, by the time we get down to Enhanced 3, you can pick out each one of those mooring dolphins
right.
individually.
I
So
think
it's
it's
actually
pretty cool.
focusing and picking up each one of those pretty clearly. Especially in that spot down in the lower right of that last image, you can see both sets of pilings on
Right.
both sides of that breakwater, which is pretty impressive,
Very
actually.
impressive. I mean, and when it comes to having a res boost in the dome, you basically are making it an open array inside of a dome. So you're
Yeah.
just sharpening that beam.
Yeah,
You know.
it'll actually make it comparable to
Right.
some of the open arrays, some of the smaller
right.
open arrays. Yeah.
But one of my favorite features,
Mhm.
and I know this is one of Clayton's favorite features.
Yeah.
It's called Target Analyzer.
Yeah, I got a chance to play with this quite a bit down in the Florida Keys when we shot Fluid Connection Season 2. We used it quite a bit while we were testing it for, to see just how well it would work in such a crowded harbor. And we put together a clip of Target Analyzer in action. So we're going to show that to you now. It's pretty cool. There's some added bonuses to it as well.
Okay, just to be clear, I've just enabled Target Analyzer. To do that on the TZ Touch 3 MFD, it's really simple. We pushed all these features into the layer mode. I look at Target Analyzer, I can turn it off and on very simply. So you'll see that all the fixed targets will stay green. And anything moving at us, you'll see will turn red. So anything a threat to us moving at us at a speed of more than about 3 knots will automatically turn red, and that's a threat to us. That's the way you can easily interpret this image. So we have that one boat, and you have the other boat separating. So now there's technically two vessels that could be a threat to us, and we should be aware of them. The other vessels are basically either not moving or moving so slow that they're not really a threat. We don't have to worry about them.
So as you can see, that's why that's my favorite feature, because it's unique to the NXT series. And what's cool is, if you notice that the skiff that we were tracking, and we had all the boats tied together, so we were all kind of hopping between boats, and we could see the different systems. When I was on this boat live watching this happen, is that you could see that it's still separating the small skiff target from both bridges, both on both sides, and it kept it target red because it was coming towards us. So it was considered a threat. But what was also neat is that the cars, it was picking up the cars on the 7 Mile bridge, which that bridge is not very low to the water.
Right. How is it, like 60?
70, 80 feet, I think, off the surface of the water. So they're, quite a ways up in the air, but it was still able to pick up each individual car, and it would turn them red depending on if they were coming across the bridge towards us or not, and it would turn them green once they passed us. It was that sensitive.
Cool. That's really cool. And really impressive how it works,
Yes.
Because they use that Doppler technology to calculate.
Well,
that.
and
It's
with
actually
as
pretty
much
cool.
metal, steel, and concrete as there was in that area and other boats, you'd think that it would almost be blinded by all that stuff, but it was able to differentiate individual cars on the freeway.
That's cool. I'm jealous that you got to do that.
It was a great trip. It was really a great trip. So now that kind of gets to the end of our presentation. So what we're going to do now is we're going to jump into Q&A. I understand that quite a few people have submitted questions, so we're going to start getting into those and get as many of them answered as we can. So let's have our producer give us the first question here.
All right, so the first one is from Adrian. He wants to know, he's kind of curious about the difference between NXT and the X-Class radars.
Well, the X-Class is a Magnetron. It's still a
Yes.
Magnetron radar. So what that does, when it transmit, compares to like an older Magnetron, it have 50% more on-target power return. And where a solid state, where Clayton touched base on earlier, it doesn't use a Magnetron.
Yeah, so that's the major difference. The X-Class is putting out more power, out of the array, obviously, than a standard mag radar is, or in the past. But the difference is between solid state and mag is one's mag and one's not.
Right.
Essentially.
So Ricardo from Venezuela asks, is there any advantages to bird detection on solid-state radars over conventional radars? This is in regard to smaller radars for the MFDs.
I would say that, as far as an advantage is concerned, because with the traditional radars, especially in years past, like we mentioned, there was a special way that you had to tune them. So you had to turn your gain all the way up, you had to turn your C clutter all the way up, and it was a fine dance, if you will, to pick out a bird target and determine what it was and what it wasn't at a certain range. With the bird mode in the X-Class and the NXTs and the X-Class, it does a lot of that for you.
Right, because with the older ones, you had to find that sweet spot for that bird tuning, where this one automatically tunes for birds.
Yeah, so there's quite a bit of advantage, and I've used them in the field, and the bird mode is rather impressive. Right, actually.
So Lawrence asks, can you use Arpa or Marpa to track a squall?
So the answer to that question is yes, you could. You would have to use some other things along with it, because with a squall like that, it's going to be changing so much. So the radar would have a hard time of finding something definitive to lock onto. So you can track it. You really want to use something like target trails to kind of help track the movement of it, because it may or may not drop that target, depending on how solid or weak it is.
So Nathan says, in what areas is a magnetron radar more effective than a solid state unit? And I was thinking to myself, probably not a lot of difference other than Raycons, but maybe you could, expand upon that.
I mean, as far as like functionality is concerned, they're very much evenly matched, because they both do exactly the same thing. Right. Like we said, they do have, a mag radar is definitely transmitting at a shorter pulse with higher energy, so it's putting out higher energy out to the target to bounce off of. The solid state is going to put out a longer pulse with less energy, but it's making up for that with running at a different frequency band.
Utilizing multiple frequencies inside when it's transmitting.
But it's that, it's the maintenance and stuff that kind of differentiates them apart from it.
Right.
As far as target detection, it really still depends on power out and the beam angle. So it's not going to be a huge night and day difference. And in some cases it is, but in some cases they're pretty evenly matched.
So our buddy Chris, one of our dealers, says anybody willing to take an estimate of bird detection ranges for NXT scanners from DRS-4D, 6A, the original magnetron radars that we used to have.
Ooh, that's maybe a touchy question, because it really depends on the conditions, it depends on the radar, it depends on beam angle. But I mean, back in the old days with like probably a mag radar, we're probably seeing birds out 3-4 miles maybe.
Right.
So at least from my experience, I think I'll throw in there a little bit. The 4D NXT, usually you're talking, you're right, 3 or 4 miles. Sometimes 2 or 3. It all depends on condition. Your 6, 12, and 25. Are all capable of seeing individual birds, usually 4 to 7. Yeah. And then, flocks, in the air, when they're together are going to be much bigger targets. You can sometimes get those as far as 12 nautical miles.
Yeah, I was going to say, I've seen him in my personal experience, because when we were out, I think it was one of the Fruno Connections things or one of the other video shoots that we did, we were out with a customer, and I think we were hitting, they said they were hitting bird flocks at 10 miles.
Wow.
So, which is pretty impressive.
And Heidi asks, is the distance disadvantaged one over the other?
As far as disadvantage between mag and solid state, I mean, not particularly as far as functionality is concerned. I mean, the only major kind of trade-off, with solid advantage with solid state is the maintenance, the lower maintenance. Without having a mag to fail, they're considerably lower maintenance.
Yeah, right. So to compare them, then there's not.
No, not a whole lot of major advantage.
Right.
So Robert, made a point more than a question. He just felt like we kind of brushed over one of the advantages of the NXT over the Magnetron, which is the no warm-up time.
Right. That's actually a very good point, and thank you, Robert, for bringing that up. And we should have mentioned that other thing, is that he's right. With a Magnetron, when you apply voltage to a mag, it has to warm up, kind of like a radio tube.
Right.
They're very similar in principle, obviously not the same, but they do have a warm-up time. It's usually about 1.5 minutes or so, a minute 30 seconds. With a solid state, it's instantaneous, ready for transmit, and instantaneous off.
Right.
So there's no wait time, which is a huge advantage as well.
So can I use the wireless radar with an Android?
The answer to that is no. Unfortunately, it's not compatible with an Android. It's only compatible with an iOS device.
Okay, so iOS only.
Yep.
And I've tried to use radar on my chart plotter, but it won't line up. So what would that cause that?
Okay, so this is a very good question, and thank you for asking this, because this does come up a lot. If I had a nickel for every time I've had that question asked before. So how it works is, when you have radar overlay, you're overlaying the radar on top of the chart plotter, right? So what it uses to do that is heading from a heading sensor. right? So you have a compass heading sensor down below decks, and it's using that heading to orient the targets and line them up. If your heading sensor is wrong, now your radar targets don't line up with the chart. So the solution to the problem is you either need to A, calibrate, or B, repair or adjust the compass so that your targets line up. That's the answer to the question.
All right, so what is the difference between X-band and S-band?
Well, we touched base on that earlier. So an X-band transmit at a higher frequency and utilize all the arrays that we mentioned with our, on the recreational side. That's what all of our recreational radars are X-band.
Yeah, they're transmitting a higher frequency between 8 to 12 gigahertz.
Right. Where an S-band transmit at a lower frequency, which is 2 to 4 gigahertz.
They're a lot bigger, a lot more power.
Right.
And they use a considerably larger selection of arrays.
Right. So from
9, 10, and 12 feet. Sorry.
Yep. No, you're fine. No.
So Kevin asks, Magnetrons makes the boats very visible to other Magnetron radars. Does the solid state radar paint as brightly on other Magnetron radars screen?
I kind of understand what he's getting at. Do they paint targets any differently? No. They're both going to do an excellent job. I mean, when you compare a magnetron targets to a solid state targets, they're both going to look excellent. They're both going to paint them exactly the same way.
Do you have an external? Do you have to have an external heading sensor to do radar overlay?
That is yes.
Yes,
that's
that
the
is
correct answer. So yes, you do have to have a heading source, whether it's a flux gate compass or a satellite compass. You got to have a heading input.
That is correct.
Can I connect my tablet to an NXT radar?
Direct connection?
No. So not a direct connection, you cannot. But if you have a TZ Touch connected to an NXT radar and you have the app that we offer, then you can link that app to your TZ Touch, have full control on it.
Okay, so you're saying that if you have the NXT connected to the TZ Touch,
Right.
you can then connect the iPad to your TZ Touch and
Right.
then connect it through.
The app.
Okay.
And in relation to that radar overlay and heading question, Chris LeBose has basically said SEX20 all day.
Oh, yeah.
Exactly.
I was going to say pair that.
Yeah,
Pair
right.
with it.
I would too, because the satellite compass is not going to have problems with being out of adjustment or having issues with like magnetic interference, where
Right.
it's going to throw the compass off and you're going to have to adjust it. There's 4 little GPS antennas in that SCX20, and it's got 6 different baselines of comparison for heading, and it's going to be dead accurate, and it'll just be correct all the time.
We'll give it a second to see if any more questions
Okay.
come in, but right now it looks like we've answered all of them. Just one comment from Nathan that just says, "Good job, guys. Freno hands down makes the best radars available."
Well, thank you very
Thank
much,
you.
Nathan. We appreciate the sentiment and the comments. It's always nice to hear from our customer base that that they love our products and we're making the right thing.
All right.
So if we have any more questions come in, I would suggest that you put them towards the forum.
Yeah.
Which is the best other alternative for kind of more complex questions. That gives us, all of us experts, because I know Johnny and I are both on there,
Yep.
and there's a number of other ones that are on there too, that can help answer those questions.
Right. So, if you want to get to our forum, you can go to our website at FrunoUSA.com.
I think there's also a direct website.
A direct website was FrunoUSAForum.com.
Okay. And then also, we have a bunch of great information and videos on our YouTube channel. So we have our web series, which is Fruno Connections. We've got seasons 1, which was the retrofit on the 39 CV that we've talked about many times. Season 2, which was the product shootout in the Florida Keys, which we showed some examples of
Right.
today. And we've got a ton of other, how-to videos, tips and tricks, kind of technology showcases. All of these live ones are all up there as well. So there's a ton of good content on our YouTube channel. Go check that out. Our website, FrunoUSA.com, and our FrunoUSAForum.com.
Right.
There's a ton of information, so you guys, we put it up there so anybody can have access to it.
Right.
So that said, on behalf of Johnny and myself, thank you very much for joining us on this technology showcase. We're going to have more of these coming up pretty soon, so stay tuned for those. And everybody else out there, thank you for submitting your questions and joining us today. And to everybody out there, boat safe and stay safe on the water.